Good morning, everyone, and welcome. I'm delighted to have you here today. Today, we'll be exploring the exciting topic of the application of AI in cleanroom environmental control. We'll look at how artificial intelligence is transforming the way we manage and optimize cleanroom environments. Over the next few minutes, I'll introduce some key concepts and share insights into innovative AI applications in this field. So, let's get started and see how technology is shaping the future of cleanroom management. HVAC, which stands for heating, ventilation, and air conditioning, plays a crucial role in the pharmaceutical industry. It directly impacts product quality, safety, and regulatory compliance. In pharmaceutical manufacturing, maintaining controlled environments is essential, especially in cleanrooms where temperature, humidity, air pressure, and particle levels must be kept within strict limits to prevent contamination. Proper HVAC systems help ensure sterility and prevent cross-contamination by maintaining pressure differentials and providing filtered airflow through HEPA filters. They also support compliance with good manufacturing practices, or GMP, which are established by organizations like the World Health Organization and the FDA. Furthermore, HVAC systems protect sensitive pharmaceutical products from degradation caused by environmental fluctuations. They also create a safe working environment for personnel. Any failure or malfunction in HVAC performance can lead to serious consequences, including product loss, regulatory violations, or health risks. That's why HVAC systems are truly mission-critical in pharmaceutical operations, ensuring that everything runs smoothly, safely, and in compliance with strict industry standards. HVAC systems are known for being energy-intensive, and there's a good reason for that. They need to continuously maintain very precise environmental conditions, like temperature, humidity, airflow, and pressure. This is especially true in pharmaceutical facilities, where systems operate 24/7 to meet strict cleanroom and GMP requirements. A major reason for their high energy use is the constant need for air filtration and circulation. For example, HEPA filters require a lot of fan power to keep the air moving and clean. Also, conditioning outside air, whether cooling, heating, dehumidifying, or humidifying, takes up quite a bit of energy, especially in climates with high heat or humidity. Maintaining pressure differentials and high air change rates in cleanrooms adds to this load. These systems can't really be shut down without risking contamination or product loss, so they run continuously. That's why HVAC is one of the biggest energy consumers in pharmaceutical facilities. Now, when it comes to air changes, cleanrooms typically need between 20 to 60 air changes per hour, compared to just 4 to 6 in standard buildings. When you add the resistance created by HEPA or ULPA filters, along with the constant pressurization requirements, it really ramps up energy consumption around the clock. All of this highlights how energy-intensive HVAC systems are in these environments. They're essential for maintaining the strict standards, but they also demand a significant power supply. Let's talk about AI-driven HVAC transformation. Essentially, this means using artificial intelligence to make our heating, ventilation, and air conditioning systems smarter, more efficient, and more reliable. Traditional HVAC systems typically run on fixed settings, which don't adapt to changing conditions. But with AI, we can enable real-time monitoring, predictive control, and adaptive optimization based on what's happening around us. By analyzing data from sensors, AI can predict when equipment might fail, helping us perform maintenance proactively. It can also optimize temperature and airflow to improve comfort and reduce energy consumption, all without sacrificing performance. This is especially critical in pharmaceutical environments, where maintaining strict cleanroom conditions is essential for regulatory compliance and product safety. Overall, AI takes our HVAC systems from being reactive, waiting for something to go wrong, to being proactive and self-optimizing. The result? Lower operational costs, increased efficiency, and better control over environmental conditions, aligning perfectly with our goal of smarter, more sustainable building management. Let's talk about AI-based HVAC optimization. Essentially, this involves using artificial intelligence to enhance how HVAC systems perform, become more efficient, and stay reliable. The key here is analyzing real-time data from sensors that monitor things like temperature, humidity, airflow, and occupancy levels. With this data, AI algorithms can automatically adjust system operations to keep conditions just right. Unlike traditional HVAC systems that depend on fixed settings, AI allows for dynamic and predictive control. This means the system can respond quickly to changing environmental conditions and operational demands. As a result, we see benefits like reduced energy consumption, less wear and tear on equipment, and more consistent indoor environments. Now, this becomes especially critical in pharmaceutical settings, where precise environmental control is vital. AI-based optimization helps maintain the strict conditions needed in cleanrooms, supports compliance with regulations, and ultimately improves product quality. Overall, integrating AI into HVAC systems leads to significant cost savings, boosts efficiency, and makes facility management smarter and more responsive. It's a perfect example of how advanced technology can drive operational excellence across industries. Let's now take a closer look at the implementation plan overview. This slide provides a structured outline of how we will execute the project from start to finish. It covers the key phases such as planning, design, deployment, testing, and ongoing monitoring. The goal here is to ensure all activities are well organized and aligned with our overall project objectives. The plan also includes important details like timelines, resource allocation, roles and responsibilities, and strategies for managing risks. These elements are crucial for keeping the project on track and making sure we meet our key milestones and deliverables. In the context of HVAC or AI-based systems, having a solid implementation plan helps us integrate new solutions smoothly, minimize disruptions to daily operations, and ensure compliance with industry standards. Essentially, this plan acts as a roadmap, guiding us through each stage, helping us stay focused, and ultimately leading to a successful outcome. Now, moving on to the deployment and optimization phase. First, proactive maintenance and compliance are critical. By predicting issues before they lead to failures, we can address potential problems early, saving time and costs. Next, we have pilot testing followed by full deployment. This allows us to validate our solutions on a smaller scale, then confidently scale up once we're sure everything works as expected. Finally, ongoing monitoring and training are essential for continuous improvement. Regular monitoring helps us catch new issues and refine our systems, while ongoing training ensures everyone is up to date and capable of maintaining optimal performance. In summary, this implementation plan, coupled with proactive deployment strategies, forms the backbone of a successful project, ensuring we meet our goals efficiently and effectively. Now, let's look at the key phases for AI adoption in our project. First, we start with data collection and integration. This involves deploying IoT sensors throughout the building to gather real-time data on various parameters. Once collected, we centralize this data to create a comprehensive information pool that we can analyze effectively. Next, we move to advanced AI model design. Here, we develop machine learning algorithms tailored to optimize building performance. These models learn from the data and help identify the most efficient ways to operate systems. Then, we have BMS integration, which is about connecting our AI models directly with the building management systems. This integration allows the AI to communicate seamlessly with existing infrastructure, ensuring smooth operation. Finally, AI-driven optimization enables real-time, intelligent control of building functions. This means the system can automatically adjust settings for maximum efficiency, comfort, and energy savings. Together, these phases form a structured pathway for successfully adopting AI, aligning technology with operational goals, and driving impactful results across the building. Let's talk about IoT sensor integration. we need to install a comprehensive network of sensors throughout the facility. These sensors will continuously monitor key parameters like temperature, humidity, airflow, energy usage, and filtration efficiency. By doing this, we create an essential data backbone that enables us to optimize the HVAC system using AI-driven insights. Moving on to data infrastructure, it's crucial to develop a centralized data repository. This repository should use standardized formats, making it easier to integrate different systems smoothly. We also need to ensure robust data governance by implementing secure handling practices, things like encryption, controlled access, and audit trails. These measures are especially important in the pharmaceutical industry, where regulatory compliance is non-negotiable. Altogether, this setup allows us to collect, manage, and secure the data effectively, providing a solid foundation for smarter, more efficient facility management. Now, let's look at our approach to historical data analysis. First, we review past HVAC performance data to identify patterns and inefficiencies. This helps us understand what's working well and where improvements are needed. Next, we analyze energy consumption trends across different operational conditions, which allows us to see how the system behaves under various scenarios. We also map correlations between environmental factors, like temperature and humidity, and system performance, giving us insight into how external conditions affect efficiency. Finally, we establish baseline metrics that serve as targets for our optimization efforts. Moving on, in designing our machine learning-based algorithms, we focus on building models that optimize energy use and forecast demand accurately. These models help us anticipate needs and adjust operations proactively. We also develop fault detection algorithms to identify anomalies early, so we can address issues before they escalate. Implementing predictive analytics enables us to manage HVAC systems more proactively, reducing downtime and ensuring consistent performance. Importantly, we train these models specifically on pharmaceutical compliance requirements, ensuring that our solutions meet strict industry standards and regulations. All these steps are integral to our overall goal of creating a smarter, more efficient HVAC system that aligns with the pharmaceutical industry's rigorous standards and needs. Let's talk about our partnership with vendors, specifically those building management system vendors. Collaborating closely with them is crucial to enable seamless integration of AI capabilities into our existing systems. This means that we can facilitate real-time monitoring of HVAC performance and implement AI-driven control adjustments on the fly. The goal here is to optimize HVAC operations, ensuring they run efficiently while maintaining the strict environmental standards required in pharmaceutical settings. Now, to support this, we also focus on operational dashboards and alerts. We equip our facility managers with user-friendly dashboards that display real-time data on HVAC performance. These dashboards are designed to be intuitive, so managers can quickly interpret the information. And to make sure no issues go unnoticed, we set up automated alerts. These alerts notify managers immediately if there are anomalies, if thresholds are exceeded, or if maintenance is needed. This proactive approach helps us stay ahead of potential problems, ensuring continuous compliance and optimal system performance. Overall, integrating BMS with AI and providing these smart tools empowers us to maintain the highest standards in environmental control, which is essential in our industry. AI-driven optimization involves using artificial intelligence to make continuous improvements in system performance. It does this by analyzing both real-time data and historical information to adjust and fine-tune operations on the fly. In HVAC systems, for example, AI algorithms keep an eye on key parameters like temperature, humidity, airflow, and energy consumption. They then make smart, automatic adjustments to optimize these factors without human intervention. What's really powerful about AI is that it's not just reactive like traditional control methods. Instead, it's predictive and adaptive. This means the system can anticipate changes and respond dynamically to different conditions or operational demands. This leads to significant benefits, including improved energy efficiency, lower operational costs, and greater system reliability. In environments like pharmaceuticals, where precision and compliance are critical, AI-driven optimization ensures environmental conditions are maintained with high accuracy. It helps meet strict regulatory standards and protects product quality. Overall, AI makes HVAC systems more efficient, proactive, and resilient, aligning perfectly with our goal of smarter, more sustainable building management. Integrating AI with existing building management systems, or BMS, and legacy infrastructure can be quite challenging from a technical standpoint. Older systems often weren't designed with connectivity or standardized data protocols in mind, which can make smooth integration difficult. That's why we often need to implement middleware solutions or even upgrade the existing systems to ensure compatibility. Moving on to compliance and cost implications, these are crucial considerations, especially in pharmaceutical environments where data security and regulatory adherence are non-negotiable. The initial investment for AI implementation can be significant, but it's important to view this as a strategic move to improve efficiency and accuracy. Additionally, workforce training plays a vital role in maximizing the benefits of these new AI-driven HVAC technologies. Proper training ensures that staff can operate and maintain the system effectively, ultimately leading to better performance and compliance. So, while there are challenges, like integration hurdles and upfront costs, they're balanced by the potential for smarter, more efficient building management that aligns with industry standards and safety requirements. Now, let's explore the exciting future of HVAC systems with autonomous AI. These next-generation systems will operate independently, constantly learning and adapting to optimize their performance without needing human intervention. They will dynamically adjust set points, airflow, and energy consumption based on real-time data and predictive insights, making the entire system more efficient and responsive. Moving on, smart simulation and renewable integration are transforming how we approach HVAC design and operation. Digital twin technology allows us to create virtual models of entire systems, enabling us to test and validate optimization strategies before implementing them in the real world. When we combine this with renewable energy sources and smart grid integration, we not only boost sustainability, but also significantly cut down the carbon footprint of pharmaceutical facilities. Overall, these advancements highlight how AI and innovative technologies are shaping a more sustainable, efficient, and intelligent future for HVAC systems, aligning perfectly with our ongoing efforts to improve operational excellence and environmental responsibility. Let's talk about adopting AI-driven solutions to make pharmaceutical HVAC systems smarter and more sustainable. By leveraging advanced intelligent automation, we can transform how facilities control their environments, leading to measurable improvements in performance. This isn't just about efficiency, it's about ensuring strict regulatory compliance while optimizing operations. Using AI, we can lower operational expenses, which is a huge benefit, and also strengthen GMP compliance, giving you greater confidence in your processes. Plus, these solutions help future-proof your facility, keeping it ready for whatever comes next. I encourage you to connect with us to see how AI-driven HVAC optimization can truly revolutionize your pharmaceutical operations. This is the start of your transformation into a more efficient, compliant, and sustainable facility. For further support, please feel free to contact us. We're here to help with any questions or additional information you might need. Thank you so much for your time and attention today. We truly appreciate your interest and engagement. Remember, we're just a message or call away if you need anything. Thanks again, and have a great day.